Decades ago, a small crew gathered around what looked like a moving building. It growled, rolled forward, and swallowed Earth by the ton, an invention so huge that towns paused traffic just to let it cross. That was only one of 10 machines that would redefine oversized. Each has a legend, a reason, and a lesson in what happens when engineers stop asking, "Can this be done?" and start asking, "How much can we dare?" Number 1. Bagger 293. Standing beside the Bagger 293 feels like being next to a skyscraper that decided to take a walk. Its frame hums with quiet authority, steel beams stretching far beyond the reach of sightlines. This machine crawls across open pit mines, not with speed, but with mass. Each rotation of its great wheel grinding entire hills into motionless dust. Each bucket could hold what most people call a room, scooping thousands of liters in one calm sweep. A coordinated crew manages every tilt and turn, synchronizing controls as if running a mobile factory floor. Power flows through high voltage cables, trailing behind like a mechanical lifeline, fueling its endless appetite. Built for non-stop excavation, this machine challenges what vehicle even means. It doesn't visit work sites, it becomes them, a moving city block consuming the Earth one rotation at a time. Number 2. Big Bertha. Something this massive should never fit beneath a city, yet Big Bertha did. It crept below Seattle, carving passage through the soil while life on the streets carried on. The cutter alone stretched wider than an office tower is tall, a steel circle covered in teeth that chewed rock into mud. One wrong strike, however, could pause an entire project, locking progress underground for months. Behind the giant face, a system of cylinders pressed it forward with patient force. Engineers in control rooms watched numbers, pressure, torque, vibration. Every second mattered in soft urban layers. Through that balance of weight and calculation, the machine inched onward. Far below the calm sidewalks, it became an unseen architect, reshaping the ground without ever showing its scale. Size here isn't vertical, it's the power that quietly rewrites the space beneath. Number 3. Antinov An-225 Maria. An aircraft so huge it could carry smaller planes inside. This was the Antinov An-225 Maria, the flying warehouse of the skies. Its 6 engines pulled a steel body built for load, not luxury, while 32 wheels spread its weight like a moving airport. The fuselage felt less like a cabin and more like a hangar turned inside out. Inside that cavernous hold, engineers once loaded entire aircraft sections, massive power stations, and wind turbine blades. It lifted freight that no road, rail, or ship could manage. Created during the Cold War to move rocket parts too large for any other route, it became a symbol of engineering audacity. When its engines finally went silent, aviation lost more than a plane. It lost the dream that proved even heavy cargo could fly if built on imagination and steel. Number 4. Le Tourneau L-2350. The Le Tourneau L-2350 greets anyone nearby with a bucket tall enough to swallow a pickup truck in one gulp. Its tires rise higher than most people, each one a wall of rubber built to cross rough open pit terrain without pause. Yet all that mass moves with quiet precision when it starts loading a mine hauler. The steering wheel barely tilts while the hydraulic arms lift tons of rock as easily as scooping sand. Every motion demands patience, a slow choreography of weight and balance powered by a roaring 16-cylinder engine. This machine exists to match pace with the biggest haul trucks ever built. Efficiency is its language. One scoop equals several from ordinary loaders. On the mining floor, it reigns without contest, turning raw power into control and proving that perfection sometimes comes in oversized form. Number 5. Prelude FLNG. Longer than 4 football fields, yet built never to roam, Prelude FLNG floats in place like a city anchored to the ocean. Its vast deck supports processing units instead of cargo holds, turning raw gas into liquid fuel right where it's found. The question is how such mass survives cyclonic seas without breaking apart. Engineers solved that puzzle with an anchoring system that holds firm against winds and waves equal to small mountains. Inside, pipelines hum and turbines spin through day and night. Hundreds of crew live within climate-controlled quarters, surrounded by noise and light from engines that never rest. This single structure combines drilling, refining, and shipping into one continuous operation. Floating beyond national coasts, Prelude isn't a ship at all. It's proof that industry itself can drift upon the sea and stay standing. Number 6. NASA Crawler Transporter. From sea to land comes the NASA Crawler Transporter, a vehicle so slow you could walk past it, yet so strong it hauls entire rockets. Each trackpad carries astonishing weight, spreading it evenly while a hydraulic system keeps the load perfectly level. A tilt of only centimeters could disrupt balance, so precision rules every movement. The platform rolls forward on massive treads, and a crew monitors fuel, tilt, and structure stability in real time. Every gauge matters, every meter counts. Originally built for the Saturn V launches, it still moves today through Kennedy Space Center's launch paths, reworked for the next generation of rockets. It's a monument to quiet strength, proof that motion doesn't need speed to show power. When this machine moves, the ground listens before the sky answers. Number 7. BelAZ 75710. The BelAZ 75,710 rises 2 stories tall, its tires nearly matching a bus in height. Each wheel turns under loads that would crush most machines. With twin V12 engines feeding twin transmissions, it channels over 4,000 horsepower across 8 wheels, proving that balance is as important as raw strength. In the open pit mines where it works, regular trucks seem to disappear among the ridges. Ore pours into its bed until 800 tons press down, yet control remains steady. Traction systems keep this heavy frame from sinking or slipping on uneven ground. Engineers built every joint, axle, and gear to share strain perfectly. That precision allows movement where no paved road exists. The BelAZ 75710 stands not as a truck, but as the final evolution of hauling, a rolling factory where road, machine, and industry merge into one. Number 8. P&H4100 XPC. An electric arm swings forward, steel joints flexing like muscle as the P&H 4100 XPC faces a wall of rock. The air hums with stored energy, current flowing from a substation through thick cables into motors ready to strike. Inside a climate-controlled cab, an operator uses joysticks to steer thousands of tons with fingertip control. Each motion translates megawatts into smooth arcs, carving layers from the mountain one dipper load at a time. When the bucket rises, it lifts several tons of broken ore as if scooping gravel. Electric power gives it instant torque and steady pull, a leap beyond diesel's smoke and lag. This machine trades brute growl for precision charge. Watching it dig feels less like mining and more like harnessed lightning shaping the ground, strength refined by electricity into pure, seamless motion. Number 9. Herren Connect TBM. It looks like a spaceship nose sinking into stone. The Herrenknecht tunnel boring machine begins its descent. Built to carve through rock and clay alike, it moves slow but sure, cutting arteries for future cities. Despite its scale, the true surprise is motion. The whole steel cylinder presses forward continuously, even while sealing the path it just created. Behind the cutter, concrete segments snap into place, forming smooth tunnel walls as if the ground itself were self-healing. Conveyors carry debris back, while sensors measure pressure and alignment in real time. Each rotation transforms rough geology into polished infrastructure. This machine doesn't simply dig, it builds. It removes, reinforces, and advances in one rhythm. The result is an underground factory at work, manufacturing habitable passages beneath our feet, one turn at a time, until new worlds quietly unfold below us. Number 10. Walking Forest Machine. Deep in the forest, steel legs begin to move. The walking forest machine strides instead of rolling, lifting heavy harvesting arms through ground too rough for tires. Its joints extend and retract with measured rhythm, a blend of hydraulics and timing that mimics muscle and tendon. Each calculated step holds balance across roots, slopes, and stones where traditional wheels would spin helplessly. The system adjusts pressure and angle automatically, allowing the cutter to work even on steep or soft ground. Motion becomes steady, deliberate, adaptive. Inside its control core, algorithms translate terrain feedback into coordinated movement. The result feels less like machinery and more like animated structure, a design that reacts with posture rather than push. It closes the gap between mechanics and biology, a quiet glimpse of machines that now walk, think, and reshape nature by stride. Extreme scale goes beyond height or length. It's the mark of how far human nerve can stretch physics toward purpose. Every one of these machines rewrites that limit, shaping land, sea, and sky through determination as much as design. From mining giants to ocean cities, they reveal ambition balanced on the edge of feasibility. When big stops being big enough, creation itself becomes a quiet dare to reality, a challenge measured in steel and voltage. Humanity keeps answering with movement and noise, proof that imagination still outruns gravity. That will be all for today. Subscribe to our channel for more exciting content like this, and hit the notification bell so you never miss a video. Thanks again for watching.